Good evening, everyone. We are towards the night, so now we are going to continue our stream on TP. We have solved the first three questions, that is climbing stairs, Pascal's triangle 1 and Pascal's triangle 2. So we are going to continue our grind again. So I think we were here. Uh, we were here. So the last problem we solved was Pascal's triangle 2, and we discussed how a row is just series of NCRs, and we discussed about inverse factorials and all. Even though that was not the point of our discussion, our solution was based on recurrence and memoization. This NCR is more of a combinatorics and math side, and that is not the objective of today's discussion. Today's discussion is about how to generate solutions through recurrence and how to memorize, basically understand the real crux of DP. So let's continue and go to the next question, which is best time to buy and sell stock, part 1. Okay, so I've already solved this question, but let's see. You are given a prices, and basically a prices array has been given. It tells me the price of the stock on the ith day, and it says that I want to maximize my profit by choosing a single day to buy a stock and choosing a different day to sell that stock. Return the maximum profit you can achieve. I think only one transaction is allowed, right? Okay. The way I'm thinking about solving this problem is, let's go back to iPad, and let's say I have the array. Let's find the array 7 1 5 3 6 4. Okay, so this is the array given to us. So let's say I decide to buy on the first day. So in any day I sell, I will make a loss. So it's not really optimal for me to buy on the first day. If I decide to buy on the second day, the maximum profit that I can make is 6 minus 1, right? So at every point, I want the suffix maximum. Like if I decide to buy on that day, the maximum profit I can make is the suffix max from that part. So for example, let's calculate the suffix max of this array. So 4, maximum of 6 and 4 is 6, maximum of 3 and 6 is 6, maximum of 5 and 6 is 6, maximum of this is 6, and still 7. So this is the suffix max array. So at any point, let's say I choose the first point, the maximum profit I can make, the suffix max for the first index is this, which is the next element. So maximum profit is minus 1. If I decide to buy on this date, then the suffix max up of all the rest of the elements is 6. So maximum profit is 5. Let's try run this on some other test case. Let's say 7 6 4 3 1. So 7 6 4 3 1. The suffix max is 1 3 4 6 7. As we can see, this is called suffix max. This looks the problem is, any day I buy, the suffix max is the array itself. So is it 6 minus 7 or 4 minus 7? So if I decide to buy on this day, the suffix max is again 3. So there is no way I can make any profit. So of course I can set the initial value as 0, which is the minimum profit. So at every point we are checking the suffix max and see that if I decide to buy on that day, how much profit I can make. So let's say into max profit. Let's make this a small p then equal to 0. Now let's create the suffix max array. Size of that will be n, and the last element, let's say no, this n minus 1 is just the prices, and then I can think that for n minus 2, 0, and then suffix max of I. The standard way of creating the suffix is equals to max of I, comma, sorry, max of prices of I, sub max of I plus 1. Okay, so basically we are doing, like, let's see, so what we are doing is we are taking the last element, we are just copying as itself, and this, and then for this element I will do the suffix max of the rest and the max of this. While calculating this, I will use this part and max it with this. So I will use this part, I will use this part and max it with this, and to produce this result. I think this one is a better example, 715364. So the last element of suffix max is always the last element itself. Now how do we calculate the second last? We will use this and max it with this. So 6. Next I will use this and max it with this, still 6. Use this, max it with this, I get 6, and then 7. I hope I made myself clear. So max of this and this results to this. Okay, so we have calculated suffix max. Now I want to calculate the profit I will get if I decide, maximum profit I will get if I decide to buy on the ith day. So let's copy this part. Of course there is no point of buying on the last day because you can't really sell. So profit, okay, max profit we have set as 0, so I can just say max profit, max of and the current, so sub max I plus 1, so minus this current buying, so prices I, and they will return this X profit. Okay, of course there cannot be reference types in okay, prices, okay, this will not be equal to sign. Okay, let's try to submit. we got an accepted. Let's try to go to the next question. I think we are done with 121. So the next question is counting bits. Okay, so you are given an integer, return an array of size n plus 1, where it's counting the number of ones in the binary representation of I. So of course it's very easy to calculate the number of ones in the ith the so there is a pop count function. We can directly use that. We'll just iterate from 0 to n, and we will just append the pop count into some vector, and we will return that vector. I don't see any point of using dp here. Let's do it the normal way then. So result, and for 0 I think built in pop count of I, and return this. This should work, I think, unless I have made some mistake in the okay, it's telling me what function should be named. Okay, it's getting accepted for the sample, and it's accepted. Okay, if we don't know how to use this built-in pop count function, I will discuss that now. I will tell how to count the number of set bits in a number. Let's go back to iPad and discuss this. Okay, so let's say I am given a number n is 25, and I want to know the number of set bits in 25. So first I need to know the bound of n. So in this case, the bound of n is up to 10 to the power 5. So 10 to the power 5, I think 31 bits is enough. 32 bits is enough for a signed integer. So we can just say that I will check all the bits from like 0 to 31, and I will check if that bit is set or not, and I will tell you how to check that. For example, let's 5 can be written as 16 plus I think 8 is 24 plus 1, right? Okay, so 6 is 1 means for the first bit is 2 4 8 and then 16. So this is the binary representation of 25. Now we want to count the number of ones in this bit. What I will do is I will AND this with 1 and then cut it and then AND it with 1 again. I'm telling you. Okay, let's be more precise. So what I will do is, let's say n is equals to 25. In order to check if the last bit is set, so we do 25 and 1. So what will happen, that 1 1 0 0 1 to end it with 1, so the answer is 1. So that means the last bit is set. If I want to check if the ith bit is set or not, let's say this is the 0th bit, this is the first bit, this is the second bit, third bit, this is the fourth bit. What I will do is shift it that many places and then AND. So let's say I want to check if the third bit is set or not. So what I will do is I will right shift 3 times. So this will be 110. Sorry, 1 1. This will be 1 1 because you see 1 1 0 0 1. If I shift this 3 times, so this will get not be there. So this is just 1 1. And if I do end it with 1, so I get a 1. So that means the third bit is set. What about the second bit? We can take 25 and then 2 and 1. So this will be 0 because the second bit is not set. So it is just 1 1 0 0. 1 1 0 because these two will not be there. So and 1. So we get a 0. I hope you know how and or works. So this is the standard table. Okay, so it's only 1 if both of the inputs are 1. Okay. Now that we have known how to check if the ith bit is 1, so it's just like n, right shift I, and then and 1. If it is equal to 1, then I can conclude ith bit is set in n. Okay, so we will do that only. So for every number we will check from the 0th bit to the 31st bit how many bits are set, count that and append it to our result array. So let's try that. So I will have another for loop. I think it will be from 0 to 31, and we need a counter. So and I will check if ith bit is set. So I, okay, this will not be I, so let's call it bit. If I right shifted how many times? Bit times. And if I end it with 1, if it is equal to 1, or you can ignore this part, you will just counter plus plus, and let's we just say result dot pushback. Okay, let's try to run this. It doesn't matter if you run the bit from okay 0 to 31. If I set it to 30, will that work? Okay, 0 to 30 means 31 bits, but integer has 2 bits. Okay, I plus plus, no, it will be bit plus plus. Yeah, that was a mistake. Okay, it's passing for the samples. So it's just another way of implementing pop count. Let's go to the next question. Is subsequence. So given two strings s and t, return true if t, s is a subsequence of t. So I think this can be solved by two pointer. Like every time I find a match, I will increment both of them, otherwise I will increment the bigger one, or the one in which I am trying to find the subsequence. I don't see any point of DP here, but yes, this can be solved with DP. Like uh, at every point I will have a choice to take that or not take that. So let's do it by DP way. The two pointer solution is extremely simple. The DP way would be uh, since s dot length is up to 100 and t dot length is up to 10 to the power 4, so I will to t, go through every t, and I will try to form s. So of course I need to have checks that if any time my length is greater than 100 or greater than s dot length, so that is not a subsequence. That sort of that pickings will never lead to s. So let's try. I'm telling you the approach that I will use. So what I will do is, let's take the sample test case. T is equal to AHBG DC and S is equals to ABC. Of course the two pointer solution would be much simpler, but for the sake of DP, let's. So what I will do is, at every index of T, I will have a choice of picking or not picking. S will be there on the side. In the end we will check if we have formed a length that is equal to of S, then I will just compare T and S. If those two strings are equal, then I will return true. If any time we have selected that many characters that are that are equal to S and still have not formed S, then we will return false. So it's a game of picking and non picking. So like A, H, B, G, D, C, on the first character I will have a choice, so pick and not pick. If I decide to pick, so it will be A. If I don't decide to pick, it will be a null string. The next step also I have an option. I can take an H or not an H, but you see that there is no point of taking H because it will not match. And of course I will try to take only those characters that are in S. Like I will carry two pointers, but that will just make it a two pointer solution. So okay, so I will just pick randomly. So I will pick H, and then I will maybe pick G as well. Sorry, B as well. Then I am forming AHB. Now you see I have reached the length of 3 and not achieved S. So whatever I do after this doesn't matter. I cannot ever form S. This is an essential pruning step. We can go by without this pruning as well, but this makes the solution much faster. That's why. So every time we will try to pick and not pick if the number of pickings is greater than the length of S. Because you see, I'm thinking about this constraint because the length of S is very less. Okay, so let's try implementing this. So we will pick and not pick, and at any point if we form S, we'll just return true from there. So at least if one true I find in any of the case, the answer is true. So let's write. So index represents the level I'm at on T. And of course, if I decide to pick it, then formed and result. So either I pick, so first I have to check if IDX equal to t dot length, then I will check if formed equal to res, return true, false. If this is not the case, I will try to pick and dot pick. So bool pick is equals to I will just do formed plus t of I will be the new, so idx plus 1, so 1 will be the string, will be the index, I'm thinking that how will I form the TP state then? Let's do it by recurrence first, then I will think about the TP. So the T will go as it is, form will be changed and result will still be same. Dot is equal to if form size okay. Zero comma t comma let's try submitting this. Okay, IDX bool not, okay, not is a, I think it's a, okay, I think this will give a TLE somewhere, or will it get accepted because S is very small, like up to 100. So yes, this is giving TLE. Now let's try to memorize this. Like IDX can change, the formed can change. I'm thinking that say that if I find a match, then I will increment the count. But then that will be just a two-pointer solution written in a recursive fashion. How do I memorize this? Well, I can just make a map out of this then. So map of idx comma string. TP. So what I will do is this is just bool. It will accept a pair. So idx comma string. If TP of this thing is not find is not equal to dp dot end. That case through return dp of this blob. I will need this. Comma mp. Okay, I have to pass this here as well. Okay. Okay, at least just passing the sample test cases. Let's see. TLE again. So it's really not helping me to memorize this in a map fashion. it's going like if I decide to not pick ever. All I'm thinking about is how the two pointer will work probably. What is the complexity of my solution? Order of 2 to the power n. So there is the memoization is just doing nothing. Okay, let's think about okay, let's check one thing that if t of idx equal to uh, let's say formed, no, not say res dot idx. Result of p1, let's say, then return 2. So that means I will pick I will don't need the formed, need an integer p1. So if I form, if one of the matches I find, so return rec of +1 t, then p1 +1, then res, then tp. If it matches, if it does not matches, then I have to skip. So p1 will stay as it is. If it matches, I can still skip. But why will I skip if I can take it, right? Maybe, I don't know. It's like acting greedy. Like, if I can match, why will I not match? Because I want to just find if a subsequence exists. I mean, okay. Let's try running this one. Okay, so 0t, this will be 0 then. Okay, if p1 reaches end, so return true. If idx is equal to t dot size, let's try submitting this, even though I have not used any DP part yet. this is accepted without even memoizing, because uh, there is no point of actually memoizing this part. Why would I memorize this type of problem? Because I just want to know if the answer exists. And it's not that I'm telling you why memorize will not, TP is not a good fit for this problem, because you see, if I can pick, I will definitely pick, and that is going to help me later. Like, if I find a match, then why will I not pick? There is no point of not picking with the idea that I may get some profit later on. It's just, if I can find a match, I will take the match. So there is nothing dynamic about it. So this is not a good fit for TP, but as you can see, we have kind of formed a recurrence and solved this. Let's go to the next question. Fibonacci number. I think this is probably the easiest question. If you watched my previous video and solved with me the climbing stairs problem, I think this was the problem that we have solved already. I think the same code will work. That I just want to know the answer I get from the left and the answer I get from the right. I think the same code will just work. I will tell you, I will of course explain why, what is a Fibonacci number and why this will work. Okay, not directly of course, it is up to 30, so if input equal to 0, return 1, input is 0. Okay, I think the first number is n is 2, so f2 is equals to, okay, f0 is 0 and f1 is 1. F1 is 1, f2 is just 1 plus 2. Okay, I will explain of course why this is it's completely similar to the climbing stairs problem. So climbing stairs was, let's say n is equal to 100, and I want to know how many ways that I can reach from 0 to 100, right? Okay, okay. What was the climbing stairs problem? Like, I think I have this in this note only. Okay, so this was the climbing stairs problem. Now in this, we can either take one step or two step. So Fibonacci number is defined as sum of f of n minus 1 and f of n minus 2. So is it not the same as that how many ways can I form n with using numbers 1 and 2 only? So for example, let's go back. Let's say f of I know that this is f of I minus 1 plus f of I minus 2, and I know that f0 is 0 and f1 is 1. So let's say I want to calculate f of 5. So 5 will be split into 2. So this is sum of f of So f of uh, 2, 3 and f of 2. Sorry, 4 and 3 I think. 4 and 3. So f of 4 will again split into 3 and 2. 3 will split as 2 and 1. 2 will split as 1 and 0. 1 and 0. 2, 1, 0. So this is the table. Now you see, if you compare this to this uh, climbing stairs problem, let's go back. So in climbing stairs, we were kind of doing the same thing. So give me the answer for 4, give me the answer for 3. I can either take one step or two step. In this case, we were adding up the number of ways to reach. And in this, we are just doing the same thing, but in place of counting the number of ways, we are just counting the end point numbers. So that's what we have done here. Like if the input is 0, to return 0. Input is 1, return 1. Input will never be less than 0. Of course, it will be less than 0. Let's say from a 2, from a 1, I by mistake called, even though from 1 I will not call -2. So I think this will not be required. So what happens is, what is happening is, for the two base cases I have defined my answers, and I am calling for, give me the answer for input -1, give me the answer for input -2, and I'm adding up the answers. So it's the exact same definition for climbing stairs problem. I think this will also get accepted. Okay, let's solve the next question. I hope we will reach the medium part very soon. Only 1, 2, 3, 4, 5 questions are left for easy. Then we'll go to the medium problems. Minimum costs climbing stairs. Okay, so I think the cost array has been given, and in every step I can either, let's say if I'm on this particular step, I have to pay the cost for that. So initially I think I want to reach the end, I think. Okay, let's say, let's copy the question first. 10, 15, 20, and in the next I think we have 100, 1, 1, 100, 1, 1, and then 100, then again 1. Okay, sorry for my bad handwriting. Okay, first I am standing here, so outside the grid. I can either come here or I can come here. If I decide to come on 10, I have to pay its cost. If I decide to come on 15, I have to pay the cost of sitting at 15. If I decide to come at 10, then I will be here, and I have to pay ₹10 or 10 units of money. Now from 10 I can only go on to 15 or 20. So if I decide to go to 15, then the cost will be 10 plus 15, and then 15 I can either jump out to not pay anything anymore, or I can go to 20 and pay more 20 and then jump out. So of course this if someone is there any negative costs? No, there is no concept of negative costs. So of course I can traverse the entire array and pay the fine just jumping 1 1 1 1. But since we have the option of jumping 2 steps, we can be smart about it. So for example, if I first decide to jump on 15 and pay the cost of 15, and from 15 I can jump again 2 steps to jump out of the grid and just pay 15 in total. So that is probably the answer for the first one. In the second one, the idea is first jump at 1, this one, and then from 1 jump at this one, because if I jump at 100 I have to pay 100 rupees or 100 units of money. So that is not really optimal. Then again jump here, or I can just, let's say I will jump here then, and then I will cross this 100, then I will jump here, because if I decide to jump at 100 it's not really good. So I jump here and then I go out. So total cost I paid is 1 plus 1 plus 1, 2, 3, 4, 5 and 6. So 6 units I have paid. Yes, so the answer for this is 6. So at every point I have the option of paying that cost or not paying that cost. So, and of course I will be given at least 2 length grid. So I am starting outside the grid. So let's try to write down the recurrence. At every point I will have the option of picking and not picking. That will add up to my cost. Let's try. Recurrence as int idx, which will determine the level, cost, or you can say this is a running cost. Just say this is R cost, okay. Now, of course, I will need this cost vector. So either I can stay here. Initially I have the option of jumping onto the first or the second. So I will take the minimum. So return minimum of recurrence. I will call it by 0. And then of course the first cost is comma recurrence of start at 1 comma 0 comma cost, because I can start at 0 or I can start at 1. I mean start paying the cost from 1, or I can start paying the cost from the 0th index only. So let's say now if I decide to pick this index, so I can say int, okay, if of course idx greater than equal to cost dot size. So what is the answer for that? So we have already reached the end. Int pick is equals to, of course, in my current cost it will be added. So R cost, so it's like R cost plus cost of idx plus, so I will just a recurrence idx plus 1. The R cost will be changed, and of course that it's not that I cannot go on not picking any of them. I have to be somewhere like, if I have not picked the previous one, let's say I'm deciding to jump one. So idx plus 1. So jump 1 means from here I will jump one step. That means I will take this cost. This cost will be added, and then, or in jump 2, if I decide to jump this cost, so it will add to my cost. So cost dx. I don't think I will need this running cost. Two will be again paying this cost, but in place of 1 I will jump 2 steps and return minimum of jump 1. Let's try this one. Okay, I have to remove these. Okay. Okay, I think we are going index out of bounds. Okay. Let's try submitting. Even though this will be, this will give, I think TLE or MLE. Yes, TLE it's giving. We have to just memorize this. Extremely easy. Just, it's only dependent on the IDX. So I think we used to do it the visited way, so we will still follow that convention. Visited tp comma vis. So if idx tp not visit, if visited tp of, I mean idx is visited, return tp of idx. True. Okay, this will not be a semicolon. Okay. Getting impatient. Okay, in undeclared okay, dp of is visited of anything is true at first. Nothing is. Okay, I have to okay. I have to I'm supposed to write this here. Let's try submitting. The last few cases are just big test cases. Okay, so this has been solved. The idea was extremely clear that okay, not probably extremely clear. So if we are out of bounds, we return 0, because if you are out of bounds, that you have already crossed the entire world and no need to pay any more cost. If I have visited, so I will just return. Jump 1 means I will consider the cost of this current cell, and then I will imagine that I have jumped to one more step, and I will calculate the cost for the rest of the journey through recurrence. And jump 2 is basically, again, I'm sitting here, I will pay this cost, and I will imagine that I have jumped off 2 steps and calculate for the rest of the answer, the rest of the world, and then find out, let's say, while sitting at this stage, maybe the jump 1 was better or the jump 2 was better, and we will do the same for the every index. I will calculate jump 1 was better or jump 2 was the better. So it's basically dependent on the next world. So this is kind of a push DP, not a pull DP. Yeah, it is a push DP because it's going this way. Okay, let's go to the next. Okay, let's see how much time the recording has been going on. It's 1 hour only. Let's try to solve one more question. Divisor game. Okay, I've not solved this before. So Alice and Bob take turns playing a game, with Alice starting first. Initially there is a number n on the chalkboard. On each player's turn, that player makes a move consisting of, okay, choose an x between 0 and n and perform n modulo x equal to 0 and representing that number x. So basically, changing n to basically n minus some factor of n, which is not n itself. So basically any person who gets the number to 0 first wins the game. It is up to 1000. Okay, let's see. So let's say, I think n is equals to 2 with a very small n is, let's say n equal to 2. So at first the Alice can take either 1, basically a number between 0 and 2, but not 2 itself. So only 1 remains. So Alice will do 2 minus 1. So now that is 1. But now Bob cannot choose any number, because if you have got to 1, there is no number between. So there is no factor of 1 that is between 0 and 1 and not 1 itself. So Alice has 1. If n is equal to 3, so Alice has choice now. So n is equal to 2 I can check, n is equal to 3 I can take, but I don't think n equals to 1 I can take. But 2 I cannot take because 2 is not a factor of n. So first Alice does is 3 minus 1, so 2. So Bob will again do 2 minus 1, so 1. Now Alice, let's see if n is 3. First Alice will do, I can take I can take x is equals to 1 or 2 or 1 or 2. If I take x equal to 1, then n will become 2. If again takes x equal to 1, then it will equal to 1. So this Alice, Bob, Alice. Now Bob cannot make it. Then in that case Alice will try to take 2 first. But no, 2 is not a factor of 1. Let's see, I think the sequence of moves have been given. Alice chooses 1, Bob chooses 1. Okay, Alice cannot do anything if n is equal to 1. So Alice can't move. Let's see. Alice can't move. So Bob wins. So at every point I am deciding to subtract what among the factors of n. Like I'm thinking if n is odd, Bob will win. If n is even, Alice will win. If they always tend to choose 1 to keep the idea co-prime as much as possible. Let's try this, even though it probably not work. If n mod 2, so n and 1, so this is odd. Odd means who wins? False. Else return true. Of course, this will pass the normal test cases. Let's see. Okay, this gets accepted. Why did I think of odd and even? The reason for me to think that is everyone will try to choose 1 only, because that will tend to keep the game longer. So that even whatever the other person does, because n minus 1 is rarely a factor of n, rarely or not ever. So like other than 2, n minus 1 is never a factor of n. So if we always decide to take 1, it's impossible for the other person to choose n minus 1 as its factor. And the first 2 cases in which 2 in which n minus 1 is a factor, that is already solved for us. So there is no edge cases. I hope you understand. So try to think about this a little bit. Think about n and n minus 1, how n minus 1 is not a factor of n, other than 2, of course. Then you will see that why choosing 1 is always optimal. Okay, let's go to the next question. It's called nth Tribonacci number. Okay, what's the time? It's only 1 hour, 9 minutes, I guess. So it says Tribonacci is, so T0, T1 and T2 is told. Okay, so just Fibonacci with 1 extra step. So I will just copy this Fibonacci code. and I think there will not be left. So 1, 2, 3. I know that 0 is 0, 1 is 1, and 2 is also 1. And Tribonacci, we will do the same idea as Fibonacci. Return a TP, 46 is enough, and yes, the answer will fit because Tribonacci tends to get fast very. I think this should work. Wrong answer. Let's think. Visited is false. NTP and all. If n is 0, return 0. If n is 1, return 1. If n is 2, return 1. If it is visited, n is up. Okay, why is it causing problem? Like, okay, this will be n minus 3, sorry. Okay, this was simple enough. So basically the same logic as Fibonacci, just one extra step. Let's go to the next question. Maximum. So we will finish this and this. This is probably the last easy problem. From the next video, we will start with the medium questions for a given string sequence, string word or k repeating. If word concatenated k times is a substring of sequence, the word's maximum k repeating value is concatenated k times. Okay. Is 0, I understand. So we want to calculate, yes, the constants are very low. We want to calculate that up to how many k concatenations, how many concatenations will it still make it the substring of. Is it not just checking that how many times, let's say AB, is it not just checking that, let's say AB is concatenated twice. So that string, if it exists in my sequence, then that is my answer. And since the constants are very low, and so sequence, and we have a word, right? So string in word equal to word. So I will try to brute force this. If I find this while let's say it result equal to 0, while sequence dot find word is not equal to end of sequence. So I will do result plus plus, and n word is equals plus equals to word. We can't get this back. Return this result. I think there is a problem. Let's Google search to see if there is a way to check if one string appears in the other string. Check if one string let's do a private search. Check if one string appears in another string. Okay, this is the brute force way. Yeah, that's what I thought. Text.find pattern is not equal to I think I should find n word. Otherwise it will be stuck. It will keep checking that one word only. I think it got accepted. Let's do the last question. I think this will come here. Longest unequal adjacent groups. Well, look, I think it has crossed around 1 hour 20-30 minutes. Yes, so let's keep it here. We will continue from this question, and we will be starting with medium problems after this session. Thank you very much for watching. Like, share, subscribe, the jargon stuff, and thank you for watching again.